Any of this? Let's talk a little bit more about the normal microbiota. It establishes itself with the host, generally lives for the lifetime of the host or close to it, and establish symbiosis. Symbiosis is where two different organisms or populations are living together. The normal microbiota forms a symbiotic relationship which is either commensalistic or mutualistic. A commensalistic symbiotic relationship is where one organism benefits and the other is not harmed. It doesn't benefit, but it's not harmed. For example, humans have in their eyeball one nematode, which forms a commensalistic relationship with humans. The nematode does not damage the eye, does not eat the patient's cells. It must be eating the bacteria that fall into the eye. It does not do the patient any harm, but it does not do the patient any good either. So it's a commensalistic relationship because the nematode gets a home by living in the eye. There are other bacteria or other normal microbiota that form a mutualistic relationship with their host. A E. coli forms a mutualistic relationship with us. We give E. coli a home. It grows in our gut. We supply E. coli with food. E. coli helps us digest our food. So both organisms benefit. Parasitism is where one organism benefits and the other organism is harmed. A pathogen forms a parasitic symbiotic relationship with its host. The pathogen benefits because it's given a home. It can then damage the host and get nutrients from the host. Like if you kill the host cells, you release those nutrients, the bacteria can use them. So that's what a pathogen does. It forms a parasitic symbiotic relationship with the host. An opportunistic microorganism is a normal microbiota that becomes opportunistic and causes disease under certain circumstances. The normal microbiota do not normally cause disease in a healthy individual. But if the normal microbiota colonize a region of the body where they are not normally found, they can become opportunistic and cause disease. For example, E. coli is normally found in the gut, and it does not cause disease normally in the gut. We're talking about normal E. coli. So it's in all people's guts as a normal microbiota. But if E. coli were to get in the ear and then grow in the ear, it would cause an ear infection. If it were to get into the lungs, it would cause a lung infection, and we call that pneumonia. So that's where E. coli is a normal microbiota, and when it grows in places where it shouldn't, it can cause disease. Another case of the normal microbiota becoming opportunistic is with individuals with a compromised immune system. They can often become infected with their normal microbiota becoming opportunistic, such as Staphylococcus aureus is found in the nose and the throat of about 50% of Americans. Only 20% have it on their skin, but on their nose and the throat. About 50% of Americans have it. It does not usually cause disease in the nose and the throat. I'm not sure why, but it does tend to cause disease on the skin. An example of a patient with an impaired immune system getting an infection from a normal microbiota could be a cancer patient. They're taking chemotherapy that weakens their immune system, and then the normal microbiota could get established, causing infection. Like all of us have yeast growing on our skin, it's part of our normal microbiota. And if the yeast blooms, let's say the patient gets chemotherapy that weakens the immune system, and then the yeast could take off growing. The yeast is normally held in check by both the immune system and by the normal microbiota. Another example of a normal microbiota causing disease and becoming opportunistic is an AIDS patient. The AIDS patient doesn't have the immune system, the normal microbiota. If it grows where it shouldn't, there's no immune system to prevent it from growing, and then the patient gets disease. Let's change to the etiology of an infectious disease. Robert Koch showed that Bacillus anthracis causes anthrax, and this is the first time a microbe was shown to cause a human disease, or any disease, actually. He used Koch's postulates to prove that Bacillus anthracis causes anthrax. Let's go through that in detail. Trying to blow this up. There we go. So if you have a sick bunny and you isolate organisms, cells from that sick bunny, meaning bacteria, and then grow them up, purify them in tissue culture, and then if you inject a pure culture into a healthy bunny, and if that healthy bunny were to become sick, why the bunny is turned on its side because it's sick. Ah, poor bunny. Then that's pretty good evidence that this organism is causing disease, assuming this disease is the same as that disease there. Come on, mouse. This disease here is the same as that disease there. Koch's postulates stated that's not quite good enough. You need to show that this disease is being caused by this organism. So you must be able to isolate this organism from this sick individual. So if the disease is caused by this organism, and then the organism is further isolated from this individual, and then all individuals that have this disease have this organism, that's evidence using Koch's postulate that this organism is causing the disease. Come on in, show. So those are the steps we use to show that a given organism causes a given disease, but there are exceptions to Koch's postulate. What do you do if the organism has unique culture requirements and cannot be grown in tissue culture? For example, we think Treponema pallidum causes the disease syphilis, but we've never been able to grow Treponema pallidum in tissue culture. So we've never been able to get it purified, grow it up in culture, and then give it to another patient to see if they get Treponema pallidum, the disease causing syphilis. And it's true also of a species that causes a human-only disease. We've never given it to humans, to see if it causes disease, like HIV. We think it causes AIDS, but we've never injected HIV into a patient to see if they later get AIDS. So we don't use Koch's postulate in these cases. There are some other cases too. What do you do if multiple organisms cause the same disease, signs, and symptoms? In Koch's postulate, you have to have one organism that causes this disease, sign, and symptom. What do you do if there's multiple species that cause the same signs and symptoms? You can't use Koch's postulate. Like, for example, the human cold. There are many different viruses that cause the human cold. They actually come from 3 different families of viruses, one of them being a DNA virus and 2 being RNA viruses. So you can't use Koch's postulate because more than one organism causes the same signs and symptoms. And then what do you do if some species cause different diseases? Like salmonella can cause salmonellosis, and it can also cause typhoid fever. So these are some exceptions to using Koch's postulates. What do we do when we have a virus like HIV that we think causes AIDS, but we can't use Koch's postulate to show that this virus causes AIDS because of moral and ethical reasons? What do we do? Anyone? All right, we're about to run out of time, so I'll tell you the answer, but in the future, I'll just say you guys have to think about it. What we do is we do vast epidemiological studies, and then we follow some people, meaning we study them over time. We follow some people who are HIV negative, and because of their own activities, they become HIV positive. And then we follow these HIV positives over time and note that they tend to get AIDS. And that's why we know that HIV causes the disease AIDS. Any question about any of that? If not, I'm going to stop here. And I think I'm done with the class. Let me just check to make sure. Oh, nope, we don't end at 6:20. That's the normal time. We end at 6:50 in the summer. So let me go further. Glad I didn't stop it. I'm glad I checked. Go on. All right, some other terms to know for this chapter. A symptom is a change in the body function that is experienced by a person as a result of a disease, but it is subjective. An observer cannot observe the symptom. It cannot be measured. For example, a headache is something that only one person can experience. Nobody can measure the existence of a headache in another patient. So a headache is a symptom. A sign is a change in the body that can be measured or observed as a result of a disease. For example, a temperature of 38.5 degrees Celsius, which is, I think, around 102 degrees Fahrenheit, is something that anybody can measure. So a sign is something that another person can measure. Any question about any of that? Usually I just use signs and symptoms when I'm talking because I don't really care if it's a sign or a symptom. It is a manifestation of a disease, but a symptom is something that another person cannot measure. Another person cannot know that the patient has a headache. Only the person who has it knows they have a headache. A sign is something that anyone can measure. A syndrome is a specific group of signs and symptoms that characterize a disease. For example, AIDS has a specific sign and symptoms characteristic of AIDS. A communicable disease is a disease that spreads from one host to another. Measles, tuberculosis, and chickenpox are all communicable diseases. A contagious disease is a disease that easily spreads from one patient to another. Can anyone name a contagious disease Actually, that's pretty easy. A contagious disease, one that easily spreads from one to another. Give me a disease that is communicable, but is not contagious. This is a disease that can spread, but it does not spread easily from one patient to another. And I'll give you a hint. There is one shown on this slide. Anyone going to take a guess? All right, think about that. I will warn.
Chickenpox?
Say again?
Chickenpox?
No, chickenpox can easily spread from one patient to another. In fact, in the old days, they used to have chickenpox parties because they wanted their children, when they were healthy, to be exposed to it and then get chickenpox when they were healthy, because it was a minor disease and you may as well get it now when the child is healthy rather than to wait when the child is sick and then get chickenpox.
But what if you already had chickenpox?
Then you could not get chickenpox because you've already had it. You could get shingles when the virus left the latent life cycle and then re-entered the budding life cycle, but you would never get chickenpox again.
Okay. Flu?
I'm sorry?
Flu?
The flu. The flu is an example of a contagious disease. So it is not a communicable disease that is not contagious. It does spread fairly easy from patient to patient. Nobody knows a disease that doesn't spread very easily. The best one I can think of is actually, oh gosh, what is that called?
I mean, it says tetanus on your example. Tetanus.
Tetanus is not a communicable disease.
Oh, you're talking about the top still,
later.
sorry.
I'm talking about a
communicable
disease that is not.
Oh, okay.
Okay. Leprosy is actually a very good example. A disease that is communicable. It can spread from one person to another, but it does not spread easily. You have to have long-term exposure, and then not everyone can get leprosy. I think it's only about 10 or 15% of the human population that can actually get leprosy. And you need long-term exposure, so it is communicable, but it is not contagious because it does not spread easily. Another disease that does not spread easily is tuberculosis. It is communicable, it can spread, but it does not spread easily. Contagious disease is one that spreads easily. Examples of a contagious disease are colds and flus. They spread easily. COVID-19 spreads even easier. Measles and chickenpox are contagious diseases. But tuberculosis is only communicable. It can spread, but it does not spread easily. There are also non-communicable diseases, and these are diseases that do not normally spread from one patient to another. For example, when a patient gets tetanus, that bacteria is not going to spread from that patient to another normally. I can think of an example of a non-communicable disease that can spread from patient to patient, but this is very unusual. And that is if you had a cannibal eating the tetanus patient, the cannibal can get tetanus. And so the disease could spread to the cannibal. But this is a very unusual circumstance. Normally, a non-communicable disease does not spread from one patient to another. And tetanus is an example. Another one is botulism. You can get botulism by eating inappropriately canned food, usually home canned food, but it could be store-bought and canned food too. But once you get botulism, it does not spread from you, usually. So a non-communicable disease. When we're talking about disease, it's important to talk about the occurrence of a disease. To understand the full scope of disease, we need details about its occurrence. When we say the incidence of a disease, we mean the fraction of a population that contracts a disease during a specific time. The incidence only counts the new cases of the disease. It does not count the old cases of the disease. The prevalence, on the other hand, talks about the fraction of the population having a specific disease at a given time. The prevalence does count both the new cases of disease and the old cases of disease. Usually, when we're talking about COVID-19, people are giving the prevalence numbers, the number in the population that have come down with COVID-19, and that's counting both new cases and old cases. Usually, when we're talking about the flu cases in a year, we're talking about the incidence, the fraction of the population that have contracted the flu recently, so only the new cases. For example, AIDS in 2007, the incidence of patients coming down with AIDS was 56,300 cases in the United States. The prevalence of AIDS cases, though, in 2007 was 1,185,000. And that's the new cases plus the old cases. Any question about any of that? All right. Some terms we apply when we're talking about the occurrence of a disease include these here. A sporadic disease is a disease that occurs only occasionally in a population. So some people say typhoid fever in the United States is a sporadic disease. It occurs occasionally, but not all the time, and usually in low numbers. An endemic disease is a disease that is constantly present in a population. So you can say that the common cold is an endemic disease in any human population. Because as far as I know, the colds hit everywhere, usually in the wintertime. Malaria is a disease that is endemic to the tropics. So you go anywhere in the tropics, you can get malaria. An epidemic is a disease acquired by many hosts in a location at a given time. So when influenza first becomes epidemic, there's a large number of cases of the flu in one location, usually one continent, and we call it epidemic. If that epidemic then spreads to more than one continent, we call it a pandemic disease, a worldwide disease. Like COVID-19 at the moment is in a pandemic. Any question about any of that? An example of an epidemic that didn't go pandemic would be SARS. The second time that SARS hit the world, it only hit China, and so it was an epidemic in China. An epidemic, by the way, is just when the number of disease cases is significantly higher than expected. Like in the flu, normally in the wintertime, we have an endemic cases of the flu. We have an epidemic if the flu cases are much higher than normally expected. So normally in the winter, we have the flu, and that's not an epidemic, it's endemic. It has to be when it's significantly higher than normal. And we usually get the flu epidemics about every 10 years when a new flu comes along and people's immune system aren't used to it, and then we get an epidemic of the flu. We'll talk a little bit more about the flu later in the course. Am I talking about that in this course or not? I don't remember. I don't think I'm talking about it in this course. Sorry, I shouldn't have mentioned that. Any questions about any of these terms? Another way of talking about disease is talking about the severity